and then check that the derivatives are the value, the product of the two slopes at those points, the product is -1. So you can find the derivative first. So this will be 2x plus 2y dy over dx equals a. And here 2x plus 2y dy over dx equals b dy over dx. This is to be understood that it's coming from the first equation, and this to be understood as is coming from the second equation. So when I solve for the first one, dy dx from the first one, I have a minus 2x divided by 2y. Here I have to move and combine like terms, which I cannot, so I have to factor out. So this is 2x equals b minus 2y dy over dx, and this comes from the second one. So when I solve for dy over dx from the second one, I get this over this. Okay? So now I have to find the points of intersection. So I see that x squared plus y squared are the same. So ax has to equal by. So let's say I solve for y, where I have a divided by b times x. And now I will plug in any of the two equations. I prefer to plug in back in the first one to find x, because I only have one y. Here I have to plug it in twice. So I have x squared plus this squared equals ax. I will divide by x, but not before I write that one solution is x equals 0. So then I have x plus a squared over b squared, x equals a. And x will be a divided by 1 plus this. Or ab squared over a squared plus b squared plus a squared, or a squared plus b squared. So when x is 0, y is 0. So this is point A, 0, 0. And there is a point B with x a b squared over a squared plus b squared. And with y, needs to multiply this. So y will be a over b times ab squared over a squared plus b squared, and b will be simplified. So it's a squared b, a squared plus b squared. I kind of remember this. I think we did this particular problem, but maybe not. But it rings a bell. Okay, so now I have 2 points. I have point A and point B. So I determine the slope dy over dx at 1 and dy over dx at 2 for point A, and dy over dx for the second one, and dy for the first one, and for the second one. Okay. So when I plug in 0, 0, when I plug in 0, 0, it's a constant over 0. A constant over 0 is basically a vertical line. Okay, so I'm going to say vertical. So let's see what happens to this one. If this is 0, this is horizontal, and they are perpendicular. So dy over dx for 2, it is 0. So this is horizontal. So at the first point of intersection, one tangent is horizontal, the other one is vertical, and I will say orthogonal. Trajectories of each other at A. This is done. Now I have to check for B. dy over dx for 1 when I plug in this point. So, dy over dx for 1 when I plug in point B. So I have A minus 2 times the x value, ab squared over a squared plus b squared. Everything divided by 2 times the y value, a squared b over a squared plus b squared. And now I have to simplify this fully. So the top will be a cubed plus ab squared minus 2ab squared. And the denominator is 2a squared b, because after I find the least common denominator, the two denominators go away. So the top is a to the third minus ab squared over 2a squared b. I can factor out an a, and I get a squared minus b squared over 2ab. Okay, so this is the slope here. A squared minus b squared over 2ab. Now if this one is negative, this, I'm in business. If not, I have to check. So this answer should be negative 2ab over a squared minus b squared. I don't know. You just chose the problem. I have no idea if that's true. I'll have to come back and check. Okay. So now I have to determine dy over dx2, which is this. And that's my page 12. Okay, so I'm going to copy it here. Dy over dx2 is from here, so I can put this away. It's 2x over b minus 2y. Okay, and here I have to plug in 2 times x. What was x? ab squared over a squared plus b squared. B minus 2, and what was y? A squared b over a squared plus b squared. A squared b over a squared plus b squared. Okay. Good. So now the top is just 2ab squared. The denominator is a squared b plus b cubed minus 2a squared b. Okay. So the top is still 2ab squared. Here I have b cubed and minus a squared b. I will factor out in the denominator negative b, and I have a squared minus b squared. And then the top is 2ab squared. A b goes away. I have a negative in front. I have 2ab over a squared minus b squared. And now the moment of truth. Negative 2ab over a squared minus b squared. So I'll say yes, I checked. So again, orthogonal. So at b. Why? Because if you multiply these two, you get negative 1. And that means that one tangent is like this and the other one like this. So two perpendicular lines have the product of their slopes. The slope of this line times the slope of this line must be negative 1. So when you multiply these two, you get negative 1. So conclusion, at every point of intersection, the two are orthogonal of each other. So they are orthogonal trajectories of each other. Any questions on this? Nice problem you picked. Thank you.